Okay, so let's talk about Python for the C# developer. Now, the goal of this presentation for you guys is not necessarily for you to walk away being able to write Python, although you may already have experience with Python. I'm kind of assuming that you're more or less a C# developer and you're kind of interested or curious about Python and you're thinking about learning it and you'd like to know more about it. So the goal is not to learn how to program in Python, because that takes more than 45 minutes or an hour or whatever we have here, but to look at all of the features of C# and .NET that we .NET developers love and see how almost all of those have a corresponding equivalent over in Python. So I'm both a .NET developer and a Python developer, and I was very struck when I learned a lot of the moving parts of Python, how many similarities there were to C#, not just in the language, but in the ecosystem as well. Okay, so let's start that exploration, right? So we're going to start out by showing you just a little 5-minute refresher about the Python language so that the rest of the conversations that we have, make sense, basically. So maybe you haven't seen Python before. I'll show you really quick little app that we can build in Python and show you just enough so when I compare and contrast that to the C# language features, you'll be like, oh, I see how this is working, right? We're going to look at a bunch of cool features of C#. I made a list of, like, if somebody came up to me and said, hey Michael, what's awesome about C# and .NET? This is the list of things that I would say this is why it's awesome. And we're going to sort of do a compare and contrast with Python for sort of feature by feature. And for many parts, Python has as nice of a feature set as C#. Sometimes Python is actually nicer, and sometimes it's not quite as nice. And so we'll sort of see the whole spectrum of how that compares. All right, so what is Python? If you guys have not used it, it's a dynamic language, a high-level programming language. It's often sort of the default way that it's run is interpreted. So the Python scripts are sort of understood by the interpreter down to the bytecode level, and then it's run in the interpreter rather than compiled down to machine instructions. But it can be JIT compiled, as we'll see. It's very object-oriented. There's 2 versions of Python, Python 2 and Python 3. And Python 3 is especially object-oriented. It's strongly typed, but it is a dynamic programming language. So there are classes and there's inheritance and all those kinds of things that you know and love from C#. And it supports all sorts of redistributables, so you can create the equivalent of like assemblies in Python and share those and so on in a really fairly efficient way. Often you'll hear people say that Python comes with batteries included, and you could say the same thing about .NET actually. It's not a common saying, but what they mean when you hear that, because you're going to hear that often as you explore Python, is there's a whole bunch of libraries that come with it. Unlike, say, C++, where you kind of just get the language and a few libraries, you get a bunch of stuff. Just like the .NET ecosystem has the base class libraries, there's something very similar here, and there's also a very vibrant ecosystem outside of that as well. Okay, so let's look at the shape of a Python program really quickly. This is probably the most striking difference from what you guys are used to in C#. So in C# or C or C++ or Java or many of these C derivative languages, blocks of code are defined with curly braces. If statements have curly braces, methods have curly braces, classes have curly braces. Curly braces are the sort of scoping block thing. In Python, we don't do that. We use white space and colons. So you can see each colored piece here is what's called a code suite or a block, right? So let's just stick with code block because that's sort of where all the C# guys' minds are. And the way you define these is you have a colon and then you have an indentation here. And usually that's 4 spaces. The editors make this really easy. You just hit tab, it turns them to 4 spaces, things like that. But here's an else, right? You could write this code in C# above more or less. But down here you actually have a bigger suite because you have everything indented, and then when you unindent, it drops back off to define another section. Okay, So we're going to see that there's this sort of different way of defining blocks of code, and that's probably the biggest thing that gets your mind around, that you don't use curly braces and that white space is important. Okay, so let's spend just a few minutes doing a language demo here, and then we're going to go do the compare and contrast. So let's go ahead and start out with my favorite IDE for Python, which is PyCharm. So we're going to create a new project here. And let's go put this into demos, and I'll just call this Python, let's do it up here, Python for C#, and of course, put that in demos. Okay, so we're going to create an empty project, but I could create like different types of web projects, Google App Engine projects, and so on. We're just going to start with an empty project, and we're going to use, let's say, this 32-bit interpreter here. We might change that as we go along. So of course, when you often see people do Python, you'll see them do things like this. You'll see them just say Python, if they could spell Python, and they'll say, you know, name equals Ted or something like that, and they'll just start typing in the interpreter. And you can do that, of course, or you could use other editors. But I definitely like IDEs, so we're going to go with that. All right, so let's start out and create a new Python file. We'll just call this language.py. Here. Now, what we want to do is let's write a couple of functions, maybe a little app that is going to use just sort of some randomness to predict the weather, you know, as good as any weather report probably. So what we want to do is we want to have a main method. So the way you define methods in Python is you say def. And you don't say the return value. There's always a return value, and it's kind of dynamic, so you don't really need to say the return value. So let's just have a main method here. Now to define a block of code, remember we have colon and then indentation. So in PyCharm and other editors like Sublime Text and so on, you just hit enter and it auto indents and it kind of knows what you're up to, which is really helpful. So I want to do a couple of things. I want to say, let's see, let's call this, let's say, days. We're going to declare a variable called days, and you don't say the type, you just say days, equals get days. So I want to basically call a function here that doesn't exist called get days, and it's going to return us like an IEnumerable, a collection of days, like Monday, Tuesday, Wednesday. And just like ReSharper for Visual Studio or Visual Studio itself, I can create this function from here using a hotkey. Just PyCharm is written by the same guys that make ReSharper, so you can imagine the hotkey is not that different. So let's go over here and let's define a list of days. And what I want to do is show you how does this compare to C# at each step. So what we're going to do is we're going to say we're going to create the days locally, and it's going to be a list. Now Python doesn't have arrays. Their array-looking structure is actually like a list of object, more or less. So what would this look like in .NET? This would be list of object. Let's call it string. List of string days equals new list of string. All right, like that. So those two lines are equivalent. And let's actually put some days in here. Let's say we have Monday, Tuesday, Wednesday, Thursday, and Friday, Saturday, and Sunday. There we go. Those are the days. And then let's return the days. Now we don't really need a method separately to do this, but I'm just trying to show you the structure in a really, really simple way. So in C#, what would this look like? Return days, semicolon. Yeah, I forgot my semicolon, didn't I? Okay. So here's our method, and then of course up here in C# this would be public IEnumerable of string, something like that, get days, like that, curly. Okay, so you can notice already that there's a lot less typing in Python, which is pretty neat. Now the next thing I want to do is, given a day, get random weather report. Given a day, I guess it doesn't really matter, does it? We'll just return something here. Oops. It's tough to mix these things. Okay, so almost typed curly braces. So colon, what I want to do now is use a class called random, And just like .NET, we have namespaces, so I need to import this. So let's go over here and say import random. There's random, okay. So that's like hash using system, yes, basically. System.random as random or something like that. So here I'll say int day equals random.next int. This is tough to write the C# and the Python at the same time. And we want to go from 0 to 6 inclusive. Okay. Actually, let's create some weather here as an array. So let's say we have a sunny, rainy, hot, and lovely. Okay. Actually, let's go up here to the length of weather. All right. And let's call this report, and let's say return report. Okay. So what we're going to do is we're going to give it a day, and for each day we're going to get a random weather report. So down here, I'm going to go through this, and what we would do in C# is we would probably write a for each loop. Okay. So over here you'll see that we can write a for loop, format a for loop. However, the for loops here are not like C# for loops. They're give some space. So they're like more like for each loops. Okay. So we'll say for d in days colon to define a new section, and then we'll say print whether on curly 0 is curly 1, just like C#. And we can say format instead of sort of doing it on the console write line. We'll see d, and then let's over here say r equals get a random weather report r. Okay, so now we're going to run this, but notice nobody's going to call main. So let me go over here and say right click and say run. And it runs down here, but nothing happened. So in these Python scripts, there's not like an entry point. What you need to do is just say run the main method. And sometimes you'll see code that looks like this. If underscore name equals main, then run this. So this, if you're importing this script, all the code that's sort of at the, not indented is going to execute if it's not defining a method or a class. So this sort of says only run this main method if the class you're running is this class. All right, so let's run this. Oh, random int is what I meant. Sorry about that. There we go. And instead of doing this, of course, I meant to say weather of that number. If you guys were not on mute, you could tell me I did that wrong. -1. Okay, so down here you can see on Monday it's going to be rainy, Tuesday it's sunny, Wednesday it's lovely, and so on. So not a very interesting application, but you can see that this is sort of the structure of the code, right? We're using colons and white space, and we're not defining our return values and our types, but it's much more sort of fluid. But at the same time, there's a lot of similarities, like for each loops, lists, random, imports, and so on. Okay, I see somebody's raised their hand. If you have a question, just go ahead and type it into the questions section, and we'll go from there. Okay, so hopefully you guys have a sense of what Python looks like if you didn't already. So now let's go look at the features of C# and how they compare. We've already seen 1 or 2 of them already. Okay, so if somebody goes and says, Michael, what's awesome about C# and .NET? Here's my short list of what's awesome. So one thing that I think is great is that everything is an object. Everything derives from system.object. So I can always call like equals or get hash code or toString, things like that. Right. IEnumerable, for each loops, very nice. And we saw actually just now that Python has that. Another thing that's really nice about C# coming from like C++ and these other languages and Java and so on is the fact that there's properties on the class. Right? So instead of having a get age and set age, I can have a property which is age, and from the outside I treat it like a variable, but it still has validation like a function. See your question in just a minute, and we'll get to it. So anonymous types I think are really nice. If you just need to sort of package up a few values together temporarily, you can create these anonymous types, and that's super neat. add reference, just the fact that I don't have to include like a header, a lib, and there's not all this like stuff to do to like use other libraries. It's just as simple as saying like add reference to the library. That's really great. NUGET, package management is great. Entity framework, great debugging tools. ASP.NET MVC, LINQ. I mean, one of the most amazing features of C# is the LINQ, so that's great. The fact we can use really rich IDEs like Visual Studio, awesome. Isolated sort of side-by-side execution, so you can have different versions of the libraries, really nice. Iterator methods from yield return. I'm not sure if you guys are familiar with this, but that's a really cool C# feature, and it's sort of the foundation of LINQ to objects, for example. Lambdas, enclosures, the base class library, JIT compilation, resharper, GUI designers like WPF and Windows Forms and so on. All the things are awesome. And you'll see that Python, for the most part, has really compelling features that are comparable with every one of these things. Okay, and we're going to do that as soon as I answer this question. What is the scope for a loop in Python? Okay, so let me see if I can address your question. So the scope, so that I guess you might be asking what is the definition of R? Is like, you know, if I had curly braces, you know, like only R would only be defined here. The definition of R, the scoping in Python is a little funky, and the definition of R is actually for the whole method. So at the end, I could just say print R. Let's say last R equals plus R, like that. Okay, it's hot apparently in the last R. So one thing you do have to sort of get a bit of a mind shift around is variable scope and things like that. But I can't down here, outside of this, after main runs, I don't believe it'll work over here. Yeah, no, exited with code 1, which if you scroll up, you can see it's like, no, we don't know what R is. So it's scoped to the method, not to like the block. Okay. All right. So one of the things that's amazing about C# and .NET, one of the really compelling reasons for choosing it, I think, is Visual Studio is such a nice editor. In Python, you guys will be surprised probably to know that there are Python tools for Visual Studio. So I can come over here, you can see somewhere I have Visual Studio hanging out, and I can say new, go down here, if I install the Python tools for Visual Studio, new Python project, look, Django, IronPython, Python app, from existing code. Let's just say new Python app. Let's just say go. Let's actually put this over in demos. Here, select. Let's call it that, Python app 1 for Visual Studio. Now, if you give it a moment, it says print hello world. Let's go over here and say days equals, let's just A, B, like that. Go down here and say days dot, look at this, append, get IntelliSense, everything, right? And then we'll just print days. If I run this, Control F5, it just runs like that. So this is really quite compelling. You can do some neat stuff here. You get the sort of immediate window, some stuff you can do with Python environments. But if you go look at the properties, if I come over here and say properties, you'll see there's just a couple of options that you get to set. If you look at PyCharm, we go over here and we look at a settings switch. If I just press the right hotkey, I'll pull up here. You can see there are a whole lot more settings. So just at the project interpreter level, there's all sorts of stuff in virtual environments and things you can do. It's just much richer in terms of like really working with Python. So Visual Studio is cool, and if you want to use that, that's great. But I'm using Python because it lets you do all the PyCharm because it lets you do all the Python stuff, not just sort of the mainstream direct basics. But that's a very neat reason. Right, but like I said, if you were going to use an IDE, I would choose PyCharm. And there's a community edition that's free, and like for personal use, it's quite cheap. So it's not as pricey as Visual Studio. The other thing that's really cool about working in .NET is you have really nice debugging tools. So I can set a breakpoint, F9, I can hit F5, and just step through it. Well, in both the Visual Studio version of Python and PyCharm, you can do the same thing, and if you set the key mapping in PyCharm right, you can still use F8, F9, F5, F10, 11, like all the various hotkeys that you even know from Visual Studio, they're the same. Okay, so there's a question. I see Python for Silverlight. Can you speak to that? Ease of integration. You know, I didn't even notice that, and I have kind of not been watching Silverlight that much lately, so I honestly don't know. I suspect that, you know, they have Iron Python, which we'll talk about, which is like a .NET, like Python on the .NET runtime. I suspect it has something to do with that, but I'm sorry, I can't say more. Okay. All right, so we saw that in C#, it's great that everything's an object, because we can say, go here, like even if I don't put :object here, it still derives from object, right? In Python, we express inheritance slightly differently, but still the same thing is true. We have a document class on both sides, and it derives from object, and even if I don't say object, it derives from object. And then that means I can do things like override the two strings. So let's go over here really quick and just create a class here. Let's go and say new Python. This will be called it overrides. Let's say that. And let's define a class called document. And even if we don't inherit from object, okay, if we want, we can come over here and say not override, but you just say def, and the way you express kind of operators and sort of the built-in stuff is with these double underbars. Under. We'll say under string. This is a string. We'll just say return. This is a document. Right? And then down here, if I create a class, I'll say doc equals document, and I'll just say print doc. Just like in C# you'd expect that code to come out. So if I run this, this is a document. Okay? So very nice. Everything's an object, and a lot of the benefits that come from being an object in C#, you see the same type of stuff in Python. Okay. We already talked a little bit about for each loops. So this is really nice. We've got a set of numbers here in C#, and the fact that we don't have to use indexes into this, we can just say for each var n in numbers and write it out. That's super nice. And we saw already that we can do the same thing in Python. We use a for loop, not a for each loop, because Python doesn't actually have the indexed version of a for loop. This is their only type of for loop. They also have a while loop, but beyond that, these are basically the looping constructs. Okay? So we saw this with our days in our language example before. So let's just keep going. There is something else that's more interesting, though. Let's see, there's a question. Let's see what that is. Can you create a simple UI component in Visual Studio? Yes, I believe you will be able to. You must be meaning create one in Python. Yes, I'm pretty sure that you can. Yeah, okay, thanks. So yes, you can, and we'll look at that in just a little bit. You would use probably something called PyQt or PySide. You could also use a different sort of UI framework that's in there. In Visual Studio, I know you actually may have a designer built in if you use PyQt as well. I haven't tried it, but I think there is a plugin for that actually. So the short answer is yes, but it's not completely simple. It's not like new WPF app, but yes, you can. And it's cross-platform, as we'll see. Okay, so we've got IEnumerable, very nice, in C#, and you can see to implement this, it's kind of painful, but you know, whatever, it's worthwhile. If we want to literally be able to say for each item in our shopping cart, instead of like shoppingcart.items or something, we need to implement IEnumerable, and if we were going to have our item stored as a string, comma, float, you know, name, price, or something like that. That's not the best way to store it, by the way, but it's the best way to make it fit on a screen. Then we would have an IEnumerable of this, and we'd write all this code, and this looks fairly painful. Let's see what this looks like in Python. So let's go over here and create a shopping cart really quick. Shopping cart. Class shopping cart, : And let's suppose this thing has like a list that holds all the items in the shopping cart. So the way you create a constructor, basically the way you create variables on these classes, is you create a constructor and you set them dynamically. So we say def under init. Okay, and then you say, notice that there's no this pointer, but self is always passed. Self is like you're this. Okay, and it's not implicit, it's explicit. So to create member variables, we'll just say, you just sort of dynamically assign them here. So we're going to assign an empty list for items. Okay, then we're going to have another method called add item, and it's going to have your self pointer. It's going to have a product name and a price. Let's just call it name and price. Okay. And in here, we're going to get our list back. We're going to say self.items. Notice IntelliSense for those items. .append. We're going to append, let me do it more explicitly for you guys here instead of inline. We're going to create a tuple, just like we did in .NET. So we're going to say name price here, and we're going to append our item. Okay? And then if we're going to implement IEnumerable, the way you do that in Python is you override under iter, so you say def under it, and then you basically need to do the same thing, return something that implements IEnumerable. So we'll just say return self.items. And if you look at the C# code when I flip back, it's going to be the same thing. So let's use this really quick. We'll say cart equals shopping cart, cart.add add item. There it is. Let's say car. It's going to be 20,000. And let's have a TV, and let's have that be 500. Okay, so then we can say for T in cart or item, say item in cart, just like in C#, let's just print out the item. Okay. So if I run this, return non-type. Oh, sorry, under iter. There you go. There we go. So we got our car and our TV, and we can just loop over this stuff. So, sorry, I skipped a step. We return basically the iterable implementation from the list. Let's flip back to the slides, and I'll answer a question. You can see that we're calling get enumerator in the get enumerator as well. So one thing that's pretty striking here is look how much simpler the Python is, but it still is accomplishing the same thing. All right, I see there's a question. Will we cover WX Python? No, probably not. Yes, spelling, yeah, sorry, okay. No, we won't, but we could talk about it afterward. Sorry, David. Okay, so the other thing that was cool, moving on quickly through the language features, is properties, right? So here I can have like a computed property even. Given my same little shopping cart item, I can say, look, I'm going to compute the total price. So I can make it look down here, I can say total price is curly zero cart.totalPrice, yeah? And from the outside, this looks just like any other variable, but it's actually computed from the items that are in your cart. We'll see that we can do the same thing over here. So if we go back to this guy, we can say def total underscore price and give it self. Okay, and then let's say total equals 0. Then we'll just say for in self.items total plus equals I dot we need the second one, and it's 0 based, so that's how you say this. In C# I'd say I dot item 2, I believe. And then down here we can just say return total. Okay. So let's down here say print total price is curly 0. Put a little dollar out there, dot format. Cart dot total price. Now look, right now it looks like a method, right? We got to call it like a method. But if I go over here and I say at property, and I come back and I get rid of this, whoops, just that one, total price, notice now it has a little p, and it's no longer a method, it's a property, just like before. Okay, so this is like the getter, basically, here, right? This is the getter. The way you do the setters is a little funkier. You say at total price.setter above some other method that sets it. Okay, but let's go ahead and run this, see what we get. Total price is 20,500. Let's say colon comma to get some commas in there. There we go. Looks better, right? 20,500. Okay, so just like C# has these properties that do all sorts of validation and getters and setters and those kinds of things, we have the same thing in Python. And again, a little bit more concise. Okay, so anonymous objects. Anonymous objects in C# came along with LINQ and the concept of sort of projecting from some set to a smaller set, or computed properties sort of dynamically through LINQ expressions and those kinds of things. So they are not super useful just sort of on their own, but in the context of projections and queries and things like that, they really are super useful. So here's how you define them in C#. If you're not familiar, probably you are, right? We just say variable O for anonymous object, whatever we want to call it, equals new, and we don't say a type, we just say curly, ID 2 registered is true, right? And just by fact that we say these things here, that will define the properties. So we can write out the object, and we get this thing that looks very much like what we wrote up there, this two-string representation, and we can work with the properties. If O.registered, go write some code. So you'll see that we can do exactly the same thing, almost, just a very slight variation, in Python. However, in order to pull it off to be 100% the same sort of experience, we really need to create a very slight variation on a dictionary. So this anon object class does two things. It basically overrides the getter and the setter for all variables of the class, the attributes, to sort of map over to dictionary get and dictionary set items, and then just internally it tracks them as a dictionary. Okay. Dictionaries are used for all sorts of internal representations and objects, not just this one, by the way. So let me just grab this code really quick and put this into an anonymous object over here. So let's go and say here's a new anon object. All right, let's just say class. Oh, actually, let me just paste. Okay, so in order to pull off this anonymous class stuff, we need this here. Okay, so let's say anon equals. Now, there's a couple of things that we could do. At the simplest one is to just use named keyword arguments. Could pass an iterable and things like that, but let's just do this. I had an ID and a registered property. So let's say ID equals 7 and registered equals capital T true. Okay, so this is very similar, although it's on one line instead of two, to what we wrote. And notice there's nowhere where we're defining these. These go into what are called keyword arguments. Dictionaries automatically map those to key value pairs, with ID being the key, the value 7, ID being, register being the key, and true being the value. So what we had in C#, as I showed you, if you had an anonymous type, I could print it out. I could say print O or whatever, and it showed you basically that representation. Oops, if I were to run this one, look at this. Almost exactly the same. ID 7 registered is true. And I even wrote this code. I said if anon.registered print they are registered. We can come down here and say else print they need to register. All right, so let's run that. Boom, they are registered, just like C#. Okay, so this is one of the places where it's not quite as nice as C#, but it's still pretty slick. Okay, pretty slick. All right, Lambda expressions. Okay, so one of the things that's fantastic about C# is Lambda expressions. These whole anonymous delegates and just you can write this really, really simple code. So over here we've got this find numbers method right here, find numbers. And what we do is it has a, basically, let's imagine like all the numbers are numbers from 0 to 100 or something like that. And what it lets you do is it lets you pass in a method, a predicate, which is a delegate built into .NET, and it's going to use the predicate to filter in and out some of the numbers. So what we're going to do is we're going to create a Lambda expression that says given a number n, it goes to, and the way you create a Lambda is this little red sign here, goes to n mod 11 is 0. So this finds all multiples of 11. If I print it out, you can see there's all multiples of 11 between 0 and 100. So could we do something that's cool in Python? The answer is sure. So let's go over here to new file, lambdas. And let me just set that as the running target. Okay, so let's create the same method. You saw I had this find numbers method. So let's say def, what was it, find under numbers. And I don't believe it took any, no, it took the predicate. So predicate comes in. Now, let's just say this. We'll say for I in range from 0 to 100. It's a simple way to do it here. I'll say if predicate of I yield, let's just say, let's just say yield I. We'll talk about yield return in a moment. Okay. So I can come down here and let me just call this. I can say numbers equals find numbers. And what do I put here? Something very, very similar. Remember C# was n goes to n mod 11 equals 0. We don't have this construct here. So we have colon, and then you have to say it's a lambda. So this is almost the same concept. Add the lambda, take away the arrows, and you've got it. Okay, so let's print numbers. Run this. I need to loop over them, so let's just say for and in numbers, print n, and here's a little trick you can do. You don't have a console write line. You only have like a, you don't have like a console write. You only have a console write line, but you can control what the ending character is. So I'll say instead of using new line characters, use this. There you go. Oop. Maybe if I had a space, it would look nicer even, right? And the space, we're in the string. There you go, so 0 to 99. Granted, there's a little funky thing on the end, but it's just a demo, right? So you guys get the idea. Lambda expressions, anonymous types, all these things that you think are like so special about C#, well, Python has them too. That's not to say C# is bad, right? C# is awesome, but the Python is awesome too, for a lot of the same reasons you think so. So here, if you want to do the same basic thing, again, look at the conciseness here. I can go create a lambda, and given an n, find me the divisors, and pass the predicate and call it, and so on. Okay? All right, so let's move on to the next one. So another one that's really, really excellent, of course, is LINQ. So when C# 3 came out, I think LINQ was really a game changer to show what you could do with static languages, what you could do with .NET. It was really super powerful. There's a bunch of different parts to LINQ, and one of the really important ones is LINQ to objects, which lets you treat anything that's IEnumerable as basically a database, and you can write queries against it. The other really super important part of LINQ is that I can do the same type of query against all sorts of different data sources. So depending on what people is in this little case here, if people is just like a list of person objects, then this is going to just use the sort of looping constructs for LINQ to objects. But if this people object is like a data context from Entity Framework, it's going to translate that to T-SQL and send that over as a projection and a where and a order by and all that off to SQL Server or some other database. If this is a MongoDB data context, it's going to turn that to JavaScript and send that over to MongoDB and execute it on the server there. So all of those things are really, really fantastic. They're not all supported in the same way in Python, but this sort of LINQ to objects, treat stuff in memory as a collection, you'll see, is more or less here. So let's go over here and write some code. I'll just call it LINQ, right? Keeping our .NET view of the world intact for a moment. Create a LINQ one and set it as the running script, okay? So over here, let's imagine we have a person class. And we'll say, create in the constructor, we'll define some variables or some attributes. We'll say self.name equals, whoops, actually, let's pass this in. It'd be easier to do this from the outside. Name and age, let's say self.name equals name. And you even have these cool little hotkeys similar to ReSharper where it'll set these variables for you. Okay, and then let's just do a toString as well, so just keep it a little clean. Reinforce that for you guys. We'll say return curly 0 is curly 1 years old. Format self.name self.age. Okay. So let's come up with a list of people, just like we had. It's going to be a list. And let's define some people here. So we'll have person, let's say Jeff, and Jeff is 20. We're going to have Tony. Tony is 42. We have Sarah, who is 30. We have Bob, who's 50, and we have Zoe, who is 10. Okay. So here's our people, and let's just, for a moment, just to see what we're doing, print out the people. All right, so let's just run that. What are we doing here? I guess I need to loop over them. All right, 4p in people, print p. That other would have worked if I had overridden a different thing. If I had overridden under representation, I believe the other one would have worked. Return self dot, like so. Anyway, okay, so you can see, let me run it one more time. Here's our people. They are basically unsorted both by age and by name. So if we had LINQ, right, if we had LINQ, we could do really, really cool stuff. Like we could say order by age, descending, where the age is greater than 20, things like that. So Python has this concept as well, but it sort of takes a different form, and it's called a list comprehension. So you got to sort of write the order differently. You don't say from P and people where this, but you'll see it's quite similar otherwise. Let's see, there's a question. How does Python compare to C# with performance, with comparable functions? So great question. How does C# and Python compare in performance? It's a complicated answer because there are many, many different runtimes. Some runtimes are like 5 times faster than other runtimes. And if your Python code is talking to databases, web services, and web clients, then it's probably pretty similar because you're really mostly waiting on databases, web network, things like that. But just purely computationally, C# is faster for the most part. We haven't talked yet about IronPython, right, which would let you write Python, which compiles to .NET, or Jython, which compiles to Java, and those sorts of things as well. So that's right. That would actually be .NET. So I suspect it would be similar. Is Python going to replace C#? Great question. I think they serve different roles. Like if you're building Windows applications, and that's all you're doing, .NET is pretty compelling, right? Because it's just so tightly packaged up and integrated. But I'm actually running this on VMware, my Windows 8 machine on VMware on a Mac. And if I copy this over to my Mac, it will run without me changing it. And I could even create like applications like exes and .app files for the OS X. And I can copy them both places and run them. And the cross compatibility is super, super neat. The one area where I think Python is really strong, sort of competing with .NET, like head-to-head, I think is probably the web stacks. They're really, really nice. The database stacks are quite close as well. Python is definitely more popular for scientific computing, even on Windows, because they've got some great scientific computing libraries, and some libraries called SciPy, NumPy, and those types of things. But the performance thing is really an interesting question. We'll get to that in a minute. Yeah, so there's a lot of similarities between F# and C#. I would expect F# to replace C# before Python does. Yeah, that's an interesting point. Yeah, I'll leave that out to the jury. So let's do this list comprehension. So what would I write? Let me write this in comments. I would say from P in people. Remember, I had something like this, where p.age is greater than 20 hash. Order by p.age descending, like so. And then I had a projection. I had new p. Let's just say p.name, p.age. Right, now technically that's the whole person, right? Because those are all the properties in my example here. But let's just assume that person has more stuff like that, like their email address or whatever. Okay, so we can write basically the same thing in Python, but we have to write them in a slightly different order. So the projection part goes first. So let's put that up here. So the way we would do that, let's create remember we had anonymous objects, and I need to use this. So let's go and import it, anon object. And note, PyCharm will actually import this, just like Visual Studio will for namespaces. And up at the top, we now have a from anon object import anon. Awesome. And we're going to say p. How are we defining this? Name name equals p.name. Age equals p.age. Now again, there's no real reason to do this projection, but we'll go ahead and do it. Okay. So then the next thing we're going to do from p in p, or yeah, we'll say for p in people. That's how you write this in this world. And then we have a where, but instead of saying where, we say if p.age is greater than 20. So excluding the order by, we can write all of this here. And let me run this and see if I got it right. Look at that. There's the people who are over 20, Sarah, Bob, and Tony. And this came out as an anonymous object. I'll show you this. We can say type of p, so you can see that it's actually an anonymous object that is this age. Okay, very cool. Now the last thing to do is the sort. I could technically put the sort inside of here, like here, but if I've got like 1,000 people and I'm really only filtering it down to have 10 people, then I would be sorting 1,000 and then projecting out. So let's do a slightly better variation here. Let's say sorted query. Then you can say key equals. So then I have to express, like, how do I sort this? So I would say key equals lambda person goes to, with a colon, p.age, and we would want to go descending, so we'll say negative. So let's run that. Now we have, whoops, query equals that. There we go. So we have 50, 42, 39 sorted, descending by age. Okay, pretty cool, huh? So let me just for a moment delete these out, so you can see that it's actually not complicated looking. It's only complicated looking because I have all this stuff together there. All right, so here is my, basically the equivalent of my link to objects. You'll see there's a link to like Entity Framework as well, but it doesn't like bind together exactly in the same construct. You got to do one or the other. Okay. All right, so I see there's a question. Let me see what it is. Does Python code run on mobile devices? I believe you can get it to run on mobile, at least on Android, but not very well. There's something called, I believe it's Py OBJ-C for Python Objective-C, which you can get it to run on like Objective-C, like Cocoa stuff in on OS 10, but I don't know for sure if you can write like iOS apps, because they're more locked down. I'm pretty sure you can't. Pretty sure you can't do it for Windows Phone, but you do have IronPython, so maybe you could do IronPython on there. But mobile is not a super compelling variant of Python. There's a lot of stuff that is really compelling. That one's not as compelling, which is unfortunate. The community's talking about it, working on it, but they don't have any sort of thing that I know of yet. Okay. So LINQ, if somebody says, what is the top 5 most awesome things about C# and .NET, definitely LINQ lands in there. And look, almost line for line, we can do the same thing with Python. You've got to reorder it. So like when you say where, it goes to this if block. And when you say order by, it's for performance reasons, I put it outside. This is using the .sort rather than sorted method. It's either are fine. Here's your projection with our anonymous object we already talked about, and so on. Okay, another thing that's super awesome about .NET is NUGET. So let me look at your question really quick. Is Visual Studio supporting Python? Yes, you have to go get the Visual Studio tools for Python, and then you must have missed it at the beginning, but we ran some Python code in Visual Studio. So yes. Which database is preferred for Python? So there's a wide variety of databases supported, and it sort of depends on what you're doing. There's SQLite, which is free and embedded. It's kind of a little like SQL Express, but more like local DB for .NET, I suppose. And that's like in process, so you don't even have to install anything. Like it comes with Python, the database, and it just either works in memory or on a just like a local single file, which is great. Then MySQL is really popular for relational databases. However, you can definitely talk to Oracle or SQL Server, Microsoft SQL Server, no problem. You've got to install like a driver library sort of thing, but it's no problem. You can do that. Another one that's really popular is MongoDB. So if you're doing anything with like NoSQL, MongoDB is super nice because the API is like incredibly close to Python already, so it's very a natural fit. If Python were rolled out, what are the minimal requirements for the end users? So that is a great question. If you give them, so it depends on how you install it. If you just say, here is my script, go and run it. And if your script is using like a third-party library, like we'll get something from NUGET here in just a minute. If you were doing that, then you would have to have them install those in their Python, which is painful. You can create a local environment, and you can kind of have them sort of take that environment and use it. That's not super great. You can create bundled EXEs or apps that suck in all the libraries they require, and then they don't have no requirements. So it depends on how much effort you want to put into building the redistributable. And are you building EXEs or executable applications, or are you building libraries, right? So there's a different way to express library dependencies and stuff, which I don't think is what you're asking. So hopefully that answers both. Yeah, okay. So it's different for them. It's different, but the libraries are actually typically simpler than the standalone apps. All right, but let's keep going so we don't get. I love the questions, but also let's at least sort of get through the topics really quick. So NUGET is super awesome. I can go over here to Visual Studio and say right-click, manage NUGET packages, or I can go to the package manager console and type install console, and here's the Mongo C# driver. So if I want to talk to MongoDB from C#, this is what I do. You'll see that over here, I can go and actually I could run a command line thing, or I can even go to the settings for my project over here. This is partly why I like this better than I like Visual Studio, is it has support for all this, is I can go over here and I can say install, and this is like NUGET. I can say I want PyMongo. Here's my PyMongo thing to talk to MongoDB, just like I showed you in C#, right? Hit install on this button and you're done. It's not always as clean because sometimes these have dependencies where there's some compilation that has to happen for C extensions and so on, but still you can more or less just either command line or through the UI say go get this thing off of what's called Python package index. If I'm a beginner Python in Django, I have experience, which ID would you recommend? Not PyCharm? Well, PyCharm is like $29 or $99 for individual use, so it's pretty cheap. If you really don't want to use that, Visual Studio, if you're a C# developer, I'm guessing, if you have Visual Studio, that would be my second one. My third one, this is a good question, my third one, sticking with this, would probably be, you can run this thing called PyDev, which is an extension to Eclipse. Let me pull this up here really quick. And here, actually, I was doing some PyDev work. Cool, just some random stuff. I was working on a class that we're writing, so I was just playing with this. Here you can see here's like the layout of my class and so, my thing, and I can run it. And then here's my stuff. Okay, so this is 100% free, but it's kind of painful to set up. You got to like go Google how to install PyDev into Eclipse. Okay, so you get the regular Eclipse and then you add on this like PyDev package. Okay, but that would be my number 3, and number 4 would be Sublime Text. Okay, so we have NUGET, this package management, and you might be thinking, well, NUGET is super awesome because there's 17,000 libraries I can get off of NUGET. That is awesome. Python has 37,000. Okay, so Python, batteries included, just like .NET, right? Lots and lots of stuff, lots of open source, a lot of community, and a lot of built-in. .NET's built-in library is bigger. Python's non-built-in library is bigger, I would say. So, pretty fair. All right, just for the sake of time, I'm not going to do a demo on this one because it takes a while, but I'll just show you. If I wanted to create something, a method I can call that does not actually compute immediately all the values and then return them, but computes them on demand, I can use this yield return keyword in C#. So like notice here's all the Fibonacci numbers. This method will give you all the Fibonacci numbers from 1 to infinity, or 1 until you run out of time or out of memory or whatever. Technically it'll overflow the integer and go crazy after a while, but because it uses yield return, it's going to return them all right away. And you probably already saw this from earlier when I was messing with it, but Python has the same thing, and it's quite a bit simpler. All right, here's the infinite series of Fibonacci numbers written in Python, and you would loop over them. Either of these would use like foreach in Fibonacci generator, right? Okay, another reason that you love .NET, I love .NET, is ASP.NET and ASP.NET MVC. Python has 3 really nice web stacks as well. Pyramid is my current favorite one that I'm working with. Django is a little more like Ruby on Rails, a little more sort of follow down this path, and Python is a little more just, here's a web request and here's a templating language and go put it together how you like. And a third one that's popular with people that I know and work with and stuff is Flask. So Flask and Pyramid are what are called micro frameworks. They're like just add little bits as you need it, and it tries to stay simple and out of your way. And Django kind of tries to be like all inclusive, helping you out, like really go to the other end of the spectrum. So if you want more like raw web, go with the top and the bottom. If you want like something more like web forms a little bit, I mean that's a pretty loose association, but something that kind of is there to help you more, go with the Django. Entity Framework, I talked a little bit about LINQ and all that, and Entity Framework is really nice. We'll see there's something called SQL Alchemy. SQL Alchemy lets you write things like LINQ queries against in-memory objects and do ORM type stuff, and those queries get mapped into SQL code, just like LINQ to Entity Framework does. The syntax is not identical to the list comprehension I showed you, but it's very familiar and friendly to Entity Framework folks. And it also talks to multiple databases, SQLite, Microsoft SQL Server, MySQL, and Oracle, and a bunch of others. Okay, so just like Entity Framework talks to many database providers and like translates from one to the other, so you don't have to worry about that. Same thing with SQL Alchemy. Very nice. We talked about performance. The default version of Python, what you've seen me working with, is called CPython, and CPython is interpreted. It's pretty fast, but it's not crazy fast. It's not as fast as C# or C++ or something like that, right? But there are many of these types of things, but there are 3 really popular higher order runtimes. So instead of running our code using CPython, we could run it using something called PyPy. And the benchmarks say that PyPy is something like 5 times faster than regular Python. The drawback is it doesn't support as many libraries, and if there's C extensions in the third-party libraries you're using, they don't work in PyPy. So it's basically a subset of Python and a subset of the libraries, but for those that it works on, it's faster, like SciPy and NumPy and those things I believe are supported there. Then if you're into .NET, IronPython is really cool. So IronPython lets you write Python and then compile it and run it on the .NET runtime using all the .NET stuff, and you can expose your Python classes to .NET C#, and you can import C# libraries into your Python code. All right. What IronPython is for .NET, Jython is for Java. Runs on the Java runtime. Expose your Python to Java library stuff exposed back to Python. So when you talk about performance, you got to be a little bit careful, because you could choose one of these things and it could have a very different performance characteristic. If you're curious how to run it, let's see. Let me go over here and open up this folder, Show in Explorer. So I have the path. And if I go, I believe I have a C:\python/pypy. Is it Python? Oh, no, that was where I want to go. Bin. Sorry about that. PyPy. There we go. And if I want to run this / let's run our LINQ one. There you go. So there we just ran a JIT compiled version of that code, right? And the second time it should be much faster. So the question about performance gets pretty interesting. That said, for the most part, I believe people are using CPython for what they're doing. Okay. All right, GUI designers like WPF, Windows Forms, super awesome. This is an area where Python is not as awesome as .NET, not really that close, but there is something called a Qt framework, which is a cross-platform Linux, OS X and Windows sort of native-looking toolkit, and there's two libraries for talking to it: PyQt, PyQt, and PySide. PySide is a little more generous on the licensing side. PyQt is basically, you can really only do like open source stuff with it. And then there's a designer called Qt Creator. So you can create some really nice apps. I've seen some nice native looking apps on Windows created with Qt, but they were done in C++, but you could do it in Python just as well. Okay, so hopefully you guys feel like you get a little better sense of what Python has to offer. I feel like .NET developers look at like the interpreted aspect, the dynamic aspect, the white space sort of code block definition stuff and go, whoa, this is really weird. This is so different than what I'm used to. It is different, but at the same time, it's very familiar. Many of the things you're like, well, how could I live without this? Well, you don't really have to. It's kind of part of Python. It's just a slight variation on it. All right, so we saw that Python has basically equivalent features for many of these things. Sometimes they're nicer, sometimes they're less nice. But for the most part, the code we wrote was like 2/3 or half the size, which is pretty compelling. It's pretty nice. All right, and we've got some really nice IDEs. We've got PyCharm, which is my favorite. We've got Visual Studio, and we've got PyDev, and there's others as well. So anyway, that's what I wanted to show you guys today. Thanks for coming, and let's go ahead and see if there's any questions. I see a few coming in. What are the pros and cons to Python? So I suspect it depends on what you're trying to do, right? Some of the cons are you have less, the compiler doesn't help you as much. Like you could write bad code in one of the if cases, and if that if case never hits and you're testing or running of your app, that will never be a problem, but maybe a user will discover it later. So things like unit testing become more important in Python. There's really nice unit testing runners, by the way. The other is you can't compile it down to kind of be completely hidden. It's hard to make like a native version of stuff. Even when you compile it as an exe or whatever, you still end up with sort of Python scripts. So kind of like .NET, you can kind of disassemble it, so that's a problem. Yes, there's a recording of this. Is Python from Microsoft? No, Python is definitely not from Microsoft. It's a guy named Guido van Rossum, and he created this around 1990. But Microsoft does support running Python on Azure, and they do have Visual Studio tools for Python. So they're not like anti-Python. Where would I want to use Python versus C# and .NET? So this sort of gets to the pros, which I didn't quite finish answering, is if you want to do something cross-platform, it's super easy with Python. Like literally I could copy all the code over to my Mac or to my Linux VM and just type Python this, or add a line to it and just type the name of the file, and it would run, and it would run fine. Okay, you can't do that with .NET. So anything cross-platform. I think the other benefits get to be a little more subjective, a little more like up to the developer. So I really like the sort of conciseness. Like let me just flip back to an example here. Move that out of the way. You guys probably can't see that little UI thing, but it's in my way. Like when I look at this code versus the other code, this just makes me really happy. I'm like, oh, look how nice it is. It's just like right there. I don't have to mess around with all this stuff. And I find when I go write Python for a while, then I go write .NET, I'm like, why am I writing all these curly braces and parentheses? And why do I have to say while parenthesis true? Why can't I just say while true? And when I first learned that, I'm like, gosh, this is so bizarre. I can't stop writing the parenthesis, and it technically would run, but it's not, very helpful. But once you get used to it, it's really nice. And so there's a lot of community libraries that you can go get from like PyPy. There's a lot of neat things about the language, but it's a little more subjective, right? It's like, why choose Java over C# or something at that point. Memory footprint of Python. So Python's memory, I think, would be probably better than .NET. It's hard to say, right? What are you doing? How does it use its memory? Like what data structures are you using? So take this with like 10 grains of salt. But the runtime is super simple, and it's basically tokenize the script and then execute it on the CPython runtime for the most part. And the way that it actually does memory is these things are cleaned up like as you stop using them. So if I say down here, people of 0 equals null, it's nothing, that would trigger delete immediately on this object. Right? So it doesn't use sort of a pre-allocating GC, and for that reason I think it would probably be pretty lightweight. But let's just say input here, press any key to exit. Okay. Okay, so that's still running. Let me go pull it up and see how much memory we're using here. Here's my Python. Yeah, okay, so here's my app. Let's go look at performance. This app is using 3.9 megs. All right, you couldn't get a .NET app off the ground for that much, I don't think. I think it would be more like 10 for starters, just because the way it does pre-allocation and stuff. But, like I said, data structures, all sorts of stuff, it can get complicated. Does Python have the equivalent of .NET generics? I don't believe so, because it doesn't have strong typing. It doesn't have static typing in the sense that you think of it. So not really. Like you could sort of add it on in certain places. So like if I wanted to make a list that would only accept person objects, I could derive from list. I could do something like this, I suspect. I could say class list of person or something like that. I mean, this is obviously not great, but I could then override this and say if the type of the thing you're adding in there is wrong, then crash, or, if it doesn't derive from person. But generally, you don't find it's really necessary so much because you don't have as much strong typing in the language, even though all the objects you create are like strongly typed objects with inheritance. The structure of passing variables around and declaring them and parameters and all that, they're not as strongly typed, so you don't really need it as much. So you don't do any upcasting, basically. You don't get the safety from the generics, but you get the flexibility, plus some problems, I guess. All right, so those are all the pending questions. I'll give you guys a minute or two to ask any more questions if you have any, and then we'll call it a wrap. But while I'm waiting, I just thank you everyone for coming today. It was really nice to talk to you about this. Hopefully you found it interesting and valuable. So final thing, I will put this up online at develop.com webcasts. Right here in the recorded section, you should see these somewhere. And when you get there, I'll put the demos, and you'll see the demos are downloadable here, and the videos, of course, at the top. Okay, one more question. Any security concerns with Python? I think nothing jumps out to mind other than the fact that your code is basically there as a text file, right? So, if people can mess with the text file, they can mess with your code, right? It's not like it's digitally signed or as a strong name or anything like that. There may be other ones, but that's the one that comes to mind. But then again, if somebody can start messing with your file system, you're kind of toast at that point anyway. They could just change your, your Windows. I don't know of a way to completely compile the stuff. Just like .NET, you can't really get around it in .NET either. Even if you use strong names, unless you've gone into like your machine config sort of settings and said explicitly only run these assemblies from these trusted vendors where these are the strong name certificates, which nobody does that, by the way. You could take even an application with strong names, disassemble all of it, and recompile it, including the exe, with no strong names, and you've got the same problem. It's just less work to do it in Python because it's a text file. Exception handling, great question, is almost identical. So the question is, what is exception handling? You're welcome. So what's exception handling look like here? You have very, very similar stuff. New Python file, exceptions. So you can create your own types of exceptions. So class, like in .NET, exceptions end in the word exception. Here they end in the word error, just by convention. So I'm going to call this like Michael's error, and it's going to derive from exception. And we won't do anything. We'll just inherit the base or whatever. And you can say pass if there's like no implementation instead of open close curly. Okay, so let's say def bad method. We'll say this. We'll say instead of throw, you say raise. Let's say raise first an index error. Index out of bounds, buddy. Whoop. So down here I can, if I try to call bad method, set this as the running script. Must have missed. Okay, run that one. There we go. You see, there you get this thing called a trace back, which is like the stack trace, but in reverse. And then you get this index out of error buddy. So I could say try colon. Instead of catch, you say except. If you spell accept, and say print. Oops. Curly 0 dot format. And let's say exception as e. Format e. Okay. Now if I run it, say oops, index out of bounds. So very, very similar, and I could even do this. I could have multiple blocks like you would in .NET. Michael's error as me. Oops. Something like that, right? So if I change this, well, first run it like this way, you'll see it's going to crash because I didn't get that right. Actually, it took it, but okay, so it's still running the bottom piece. But if I change this to be Michael's error, and I run it, dope, right? There's my catch up here. All right, so it's very, very familiar to .NET folks. All right, another question. Is there a good REST library you can recommend? The link to the video in this chat. Let's see. Yeah, so I I don't have the link to the video yet, but I'll post this link. Whoops. As close as I can get you for now, and then you'll have to just find it at the top of the list, okay? Okay, so there's that. Is there a good REST library? So for the server side, something like Flask or Pyramid would be pretty sweet. You're welcome, David. On the client side, what I would do is this. Let me just show you how this the NUGET stuff works really quick. Make sure to stick around, you guys. So, if, you would probably choose something like HTTP client from .NET. So we come over here and say, I want to use a certain library. So I'm going to install it using NUGET, which is I go to the interpreter, which is the one I'm using here. I believe that's the one I'm using. And you notice these are my installed packages. I could use sort of local instances, what are called virtual environments, which is what I would really do if I weren't like just racing around trying to do this demo for you guys. But I can come over here and I can say install requests here, and Python HTTP for humans, hit install package, close. You can see this little spinny thing down here. So we'll say OK. Now you see it's here. So I come over here and I would say import requests. Then I would just say r equals request.get. And if you don't know what the arguments are, you can hit Control Q in Python and it pulls it up, shows you the arguments. So I believe it's URL equals, http www.develop.com. And then we can say print .request. Let's try this. Getting request. And then down here we'll say print number of bytes. It's probably not quite right, but number of bytes equals plus request.text, and we want the length of that, so string of the length of that. Not the easiest way, I should just do format. But let's run this REST thing. Wait, getting request, got request, 3100 bytes. So here's a really cool, like super simple library for doing like HTTP client type stuff. And like I told you about the web frameworks, Pyramid or Flask is probably where I'd start. Just do like JavaScript response or something like that. There may be something better that I'm not aware of, but those are the things that come to mind for a REST client server. Like this is pretty simple, right? Batteries included. That's sort of what they mean here, right? Okay. 5 more seconds. Any more questions? If not, we'll call it a day. Alright, so I'll post the video and I'll post the demos, and otherwise, thank you for coming. You guys had a bunch of great questions. I know I didn't answer. There's a couple I didn't answer, so sorry about that. Let's see. Thanks a lot. Wonderful. Yo, you're welcome. Nancy, you're welcome. David, thanks for saying so, you guys. Have a great day. See you later.